All right, I choose this question from your tutorial and I want us to look at it quickly. Okay, so we want to solve this differential equations, and remember that d here just means differential, right? That derivative, okay, of y. So if we start with this first example, we can first find the auxiliary polynomial. What's p of lambda here? Is simple. It is lambda cubed plus 1 is equal to 0. We want to solve this. We want to solve p of lambda. So it's easy to see that minus 1 is a solution. If you take, let's say, p of minus 1, you obtain 0, okay? It means minus 1 is a solution. Then I can choose to write this p of lambda, as I already know that minus 1 is a solution. It means lambda plus 1, a lambda square plus b lambda plus c. We are looking for a, b, and c. So we have different, of course, we have different methods from school how to find the root of a polynomial. So this is just an example. So you can use any method to solve this. This is just a simple method I want to introduce here. So if we multiply this through, we obtain a times lambda cubed plus b times lambda square plus c times lambda plus the second part. If you multiply, this is a lambda square plus b lambda plus c. So if we write a lambda cube, lambda square, we write them together. This is b plus a lambda square plus c plus b lambda plus c. Okay, by inspection, we know that the coefficient of lambda cube here is 1. So it's by inspection, a is equal 1, as you can see here, okay? b plus a is equal 0. This means that b is equal minus a, so b is equal minus 1. And c, we don't need this one because we already know, we can see that c is equal 1. So c is equal 1. Then the polynomial becomes this. P of lambda is lambda plus 1. A is 1. This is lambda square minus lambda plus 1. All right. Of course, you can multiply this through and see if you obtain exactly lambda cubed plus 1. Okay, just to make sure that it's correct. I know that it's correct. That's why I don't have to do that. So at this stage, we want to find the root. The solution here will be this part equals 0 or this part equals 0. So this is lambda equal minus 1 coming from the first bracket, or lambda square minus lambda plus 1 is equal 0. So to solve this, we generally use a discriminant. So lambda is equal, the first thing here is b is 1 plus minus the discriminant square root of b squared, this is 1 minus 4 times 1 over 2. This is half plus minus I root 3 over 2. The general solution in this case is just y equal a times e to the power half of x cos root 3 over 2x plus b e to the power 1 over 2x sine root 3 over 2x. This is for this part. For the last part, the first part here is c times e to the power minus x with a, b, c all in R. So this is the solution to the first example. Okay, so once we finish with this, let's move to the second example. So for the second example, we also start with the auxiliary polynomial. So p of lambda give lambda to the power 4 plus 1. Okay, this is equal 0. We want to find the root of this polynomial. And if I want to solve this, I will say lambda to the power 4 is equal minus 1. Is it easy to solve this? I don't think so. I don't think it's that simple. But I can use a substitution. If you introduce this, let's consider a new variable here called u. We say u is equal lambda square. Okay? Then the equation becomes u square is equal minus 1. And we know that minus 1 is I square, complex value. Okay? So this means u is equal I, or u is equal minus I. So once we have this, let's then consider our original variable, lambda. So we have lambda square for the first one is I, and for the second one, lambda square is minus I. But let's start with this first. This lambda square is I. Then it means that lambda is a complex, and we know the general form of a complex is A plus IB square is equal I. Alright, if we say this, we expand this part, we have A square minus B square. This is the real part. For the imaginary part, you have 2AB I is equal I. Alright, by inspection here, the root part is 0 because this part is just imaginary. So this is A square minus B square is equal 0. And for this imaginary part, we have 2AB is equal 1. So can you then solve this system of two equations? Yes, it's doable. Solve this system of equation and we obtain A is 1 over this and B is equal 1 over this. This is for the first set. The second set will be A equal minus 1 over root 2 and B is minus 1 over root 2. So if you solve this system, you obtain exactly this as solution. Again, we repeat this process in the case of lambda. Let's take the case of lambda square equal minus I. This is A plus IB square is equal minus I. We expand this, A square minus B square plus 2AB I is equal minus I. Inspection by inspection, this is A square minus B square is equal 0. 2AB is equal minus 1. Again, we solve this and obtain A is equal 1 over root 2 and B is equal minus 1 over root 2. The second set is A is equal minus 1 over root 2 and B is 1 over root 2. So having this, we can therefore write this total solution. So this means that lambda for the first part, we have two lambdas here. The first lambda is 1 over root 2 minus 1 over root 2 I. The second lambda is minus 1 over root 2 minus 1 over root 2, plus 1 over root 2 I. It's the same for this. We have lambda is 1 over root 2. Let's say plus minus. I would like to write it like this. You understand that it's two solutions plus 1 over root 2 R. Alright, then having this, we know we have 4 lambdas, 1, 2, 3, 4. We can then write the total solution. The general solution here is, so if you want to write this, this is C1 times e to the power x over root 2 cos x over root 2, okay, plus C2 times e to the power x over root 2 sine x over root 2 plus C3 times e to the power minus x over root 2 cos x over root 2 plus C4 times e to the power minus x over root 2 sine x over root 2. So with C1, C2, C3, and C4 elements of R. So this is the solution to the differential equation B, given here in equation B. Okay? So basically here you just have to use your school techniques. So you have to first know that to solve this polynomial is not straightforward. You can introduce these substitutions. We introduce the U substitution here, the equation become a second order polynomial. U square equal -1, and we know that -1 is I square. And solving this, we obtain U equal I or U equal -I, okay? So we go back to the original variable, which is lambda. We substitute lambda, U by lambda square. Lambda square is equal I. Then we know that lambda should be a complex number. So we have to choose the general form of a complex number, which is A plus IB, okay? Square is equal I. And when we expand this, we obtain exactly this form. We have to solve this system, and solving the system, we obtain this, okay? And this is our lambda, the true value of lambda. We repeat the same procedure in the case of U equal -I, and we obtain these two lambda. And from these four values of lambda, we can combine and write the general solution. So I guess this is clear. You following my process, you should be able to solve any situation, any problem related to this type of equation. All right, that's all for this video. Thank you.